we're left to kind of deal with are called the tangential and normal components of acceleration. What that says is the acceleration vector is made up of a combination of the unit tangent and unit normal. And this number, because this is a scalar, it's a number, is called the tangential component of acceleration. And this one here is called the normal. So essentially the acceleration vector is made up of a combination of the unit tangent, right? The vector that is the direction you shoot off to your death, and the unit normal, which is that one that as you go around corners, you know, you feel that sideways motion. So evidently those two vectors combined using these fellows here will actually be the same thing as acceleration. And in a way, all you need to know is these two formula. Because the type of question you're going to be asked is, find these two guys. Either in a general format, that means your answer will have t's in it, or when t is 1, right? So you might be asked to find these two things when t is 0, t is 22, t is 1. Right. So I'm going to start with my all-time favorite space curve. And I've used this one a couple of times. Can anybody remember what the name of that particular kind of space curve is?
It's a helix.
It's a helix. And isn't this one going to helix along the y-axis? So you imagine it's spiraling along the y-axis. Now, why do I like them? Because these calculations tend to be reasonably nice, right? They tend to come out pretty good. So we're going to do this guy first. So that means the dot product of the first and second derivative divided by the magnitude of the first derivative. And this one is going to be the cross product of the first and second derivative. Then you find its magnitude. And again, divided by that guy, right? So you see that they are very similar. Do you see that dot and cross products happen in a lot of different ways, right? So I'm going to find our first derivative. Differentiate that guy, you get a negative sign. Differentiate that guy, you get 2. And differentiate that guy, you get cosine t. I'm also going to find the second derivative because both of these formula use them. And if you differentiate this guy, you get negative cosine t. Differentiate this guy, you get 0. And differentiate this guy, you get negative sine of t. Okay, that's basically what we need to get any of those. If I'm going to do the top one, I now need to find the dot product of the first and second derivative. So that guy times that guy gets me positive sine t cosine t, plus that guy times that guy gets me 2 times nothing. And that guy times that guy gets me essentially negative sine t cosine t. And I believe that that guy get killed off by that guy, and that guy is 0. So guess what? That's a fluke, but it's a nice fluke, isn't it? That the answer is 0. Now, only for completeness sake, I'm now going to find the magnitude of the first derivative, right? Because I need to know that as well. And the magnitude of this fella is the square root of that guy squared, which is sine squared t, plus that guy squared, which is 4, plus that guy squared, which is cosine squared t. And hopefully we've seen this happen enough times to realize that this simplifies, because you don't always get lucky. What does this become?
4.
Yeah. Well, 4 and 1 more, 5. Now you put that package together, and the tangential component of acceleration is the dot product of the first and second derivative divided by the magnitude of the first derivative. In this case, 0 over the square root of 5, which means the answer is 0. So the tangential component of acceleration is actually nothing. That means this piece has no influence on the acceleration vector. I have no idea what that means. I'm not into dynamics and moving objects, but I guess that would be interesting, right? That only one of the two, i.e. the normal vector, in this particular situation works. Now we are going to move on to this fella. So I now need to find the cross product. And the cross product of these two guys. So it's going to be I, J, okay. Put in this fella, negative sine t to cosine t. Put in this guy, negative cosine t, 0, negative sine t. And that's going to be so many i's, take away so many j's, plus so many k's. Are we getting, I hope we are getting so familiar with cross products. Isn't it just second nature what to do? You don't even think about it, you just write it down. I hope we're at that point. And also, it really doesn't matter if it's numbers or not. Don't you do it the same way? Right? There's nothing special. Cover that guy up then. 2 of these take away nothing, gets you negative 2 sine t. Middle one. That guy times that guy is sine squared. Take away that guy times that guy, which means you add a cos squared. So I'm now going to get a sine squared t plus a cos squared t. And then for the last one, it's going to be nothing. Take away that guy, so you end up adding it. It's going to be a cosine t. So it's negative 2 sine t. Would you agree that's 1? So this is negative 1. And that guy is 2 cosine t. Are you comfortable about the cross product? Aren't helixes nice to work with? Don't you get good math from helixes? Now, I need to know the magnitude of the cross product, because my formula has a magnitude, right? So it's not this guy, but the magnitude of this guy. So magnitude of this guy is the square root of this guy squared, which is 4 sine squared, plus this guy squared, which is 1, plus this guy squared, which is 4 cos squareds. What does that guy inside the square root look like?
The square root of 5.
Okay. I like helixes. Nice. Cancel out, combine. So to get the second filler, this filler, it's going to be the cross product, the magnitude of the cross product, which we've found, divided by the magnitude of the first derivative, which I already found earlier on, which, by the way, happened to be the square root of 5. Which means it's 1. So if they don't ask you to do this, but I like this one, so I'm going to actually do it. The acceleration vector of this helix, right? This guy here is given as this combination. But we've just found out that that guy is 0, so this disappears, and that guy is 1. So guess what? For a helix, at least this particular helix, won't the acceleration vector be the same thing as the normal vector? Right, 0 of this plus 1 of that. Now, I have no idea if that's very interesting. To me, mathematically, it's interesting, but it may have a very interesting meaning in the motion of objects in 3D space. In other words, if you spiral as you move, you will generate an acceleration force in one direction only, and that will be in the direction of how you're curving. So that would be towards the center of your spiral. How weird is that? If you're spiraling, your acceleration is only going to be in the direction towards the center of the circle of your spiral. That makes sense. I just thought of something, probably not accurate. Here's a jet. Right. Do you know when jets do that fiery thing and you see the smoke come out? Have you noticed that it goes in a spiral? I wonder if that's to do with that. Since the spiral is, since the acceleration is towards the center of the spiral, maybe that has something to do with the motion of a jet. That's why it's causing the spiral smoke. I am drifting like nobody's business right now, but my brain sometimes sees things and I go, oh, especially if it's anything to do with engineering, because engineering basically never makes sense, does it? I think most engineers are amazed when their bridge doesn't fall down on them. Oh, come on, I must be able to insult engineers. Did I tell you the joke about the OC students designing a plane?
Yeah.
Okay, then I won't do that one with you then. Did I tell you the one about the mathematician, the engineer, and the English person going in for a job?
I think last time you told it with a lawyer, but
yeah. Okay. But different joke, good. Different punchline. If you ask a mathematician what 1 + 1 is, they'll say it's 2. If you ask an engineer what 1 + 1 is, they'll tell you it's 2 ± 1. And if you ask an English professor what 1 + 1 is, they'll say, does it really matter and can't we all just be friends? No? Okay. Oh, actually somebody likes it. I'm getting better or you lot are getting worse. Okay, let's pick the other extreme. Helixes, nice numbers. Maybe I should pick one of theirs. Okay, this is a version of question 10. It's a t, it's a 2e to the t, and it's an e to the 2t. And we're going to find, I mean, this is all it says in WebAssign. Right. So you're going to be putting things in here, right? That's it, no clues, whatever. But we have the formula, right? So write that down somewhere and off we go. So pretty much it's a plug and chug process. So I'll differentiate this guy. I get 1, I get 2e to the t. And if I differentiate this guy, I get 2e to the 2t. If I do the second derivative, I get a 0. I get 2e to the t, and I get 4e to 2t. Are we all kind of comfortable about the first and second derivative? You can't really do too much damage to that unless these things are ridiculous, you know, like t over t squared plus 1. These are going to be pretty straightforward. That's what happens next is going to be a little bit more problematic. So I'm going to find the dot product. And the dot product ends up being 1 times 0 plus 2e to the t times 2e to the t plus 2e to the 2t times 4e to the 2t. And that's 0, 4e to the 2t plus 8e to the 4t. Are you all comfortable so far? Right. And actually, I should have saved a line of work and not bothered to write that, but too late now. Now, I also need to get the magnitude of the first derivative, which is going to be the square root of this guy squared. If you square this guy, you get that. And if you square this guy, you get that. And if ever I see 3 things inside a square root, aren't I going to hope that it's a perfect square? And it's a good idea to write them biggest power, less power, least power, right? And if you write them in order, this guy is going to tell me what goes here, and this guy is going to tell me what goes here. Well, obviously that one's 1. What goes here? What does that guy get you here?
2e, 2t.
2e to, how many t's? 2e t or 2t or 3t or 4t? What power of, yeah? So far so good, but not t. What do you get?
2t.
Yeah. Basically what you're doing is taking the square root, right? Square root of 4 is 2. Square root of powers basically just halves the power. So 4t gets you 2t. Square root of 1 is 1. Now that makes this guy a much nicer looking guy than he might have been. Are you comfortable with that? Okay. Dot product is this. Magnitude of the first is this. And AT, which is the one we're going to do first, is the dot product of the first and second derivative divided by the magnitude of the first derivative. And the top guy is this fella, and the other guy is that guy. So far, so good. I'm going to write this guy down again because I need some room. There's an unwritten rule which says style points, style points, style points. If you can make something nicer, shouldn't you? Now you might be looking at that and think, that's pretty good. I like that. And I do like it. It's nice. But can I do better? That's the question. And this time the answer is yes. A lot of the time the answer is going to be no, right? That's as good as it's going to get, and that's great. But this is not one of those times. Can anybody think of something you could do to the numerator that might make this nicer?
You could factor out 4e to the 2t.
You could. And if you did that, you'd get 1 plus 2e to the 2t. Right, one of these guys. 2e to the 2t. Do you see something pretty? I see smiles, so that means yes, at least some of you see something pretty going on. What can you see staring you at the face? Come on, just see it.
2e to the 2x plus 1 cancels.
And can you see how it's very easy to miss style points sometimes? The thing looks so nice, you're happy. And you should be. It's a very nice looking answer. It could have been a lot worse, right? And then you go, oh, why is WebAssign not liking my answer? Well, your answer was fine. In fact, knowing WebAssign, unfortunately, it probably would tell you that's correct, but really that's correct. That's like 4/8, and this is a half, right? And so we always do that. Right, moving on then. We're going to do the cross product of the first and second derivative. And oops, I moved the wrong guy. It's this guy I want. So it's going to be I, J, okay. And this fella looks like that. And this fella looks like that. So it's going to be so many I's, take away so many J's, plus so many K's. Right, cover it up. Major diagonal, take away minor. That's 8e to the 3t, take away 4e to the 3t, 8 take away 4, 4e to 3t. You happy about that? If you multiply those two together, you get 8, and then e to the t, and then e to the 2t gets you e to the 3t, right? So that's 8 of them, take away 4, leaves you with 4. Middle one. That guy, take away nothing, just leaves you with this fella. So that's 4e to the 2t. And the last one is that guy, take away nothing, so that leaves you with 2e to the t. So we get 4 of this guy, negative 4 of this guy, and 2 of those guys. Now we good? You know, half the time I say that is I want you to make sure that I've done my calculations right. Okay, so it's, yes, are you understanding it? But do the numbers I've got, do they match up? I can't say anything wrong, but that doesn't mean I'm wrong. Are we good? Okay, we have thumbs up. I'm going for it. I need to find the magnitude of this guy. And so it's going to be the square root of 4e to the 3t squared plus negative 4e to the 2t squared plus 2e to the t squared. I'll put it over here, I'll need the room. That guy gets you 16e to the 6t. That guy gets you 16e to the 4t. And that guy gets you 4e to the 2t. 16, yep, 16, yep, 4. Double that, double that, double that. Okay, let's go for style points. Style points, style points, style points. Anything you can see that might make that, and don't I know it's got 3 terms, and I know 3 terms mean that it could possibly be a perfect square. But let's just hold off on the perfect square for a minute and see if there's anything else we can do first. Is there anything you can do in this expression?
You can factor out a 4e to the 2t.
That's the one I'm going to do. And that leaves me with 4e to the 4t. That one leaves me 4e to the 2t. And that guy leaves me just with a 1. Now you pull that out of a square root and you pull that out of a square root, you get that. Are we comfortable with that? Now let's focus on a square root with 3 things in it. Good chance of being a perfect square, right? This time it is. That guy tells me what goes here. That guy tells me what goes here. I'm putting in the easy one. What does 4e to the 4t generate? What goes here?
Two e to the 2t.
Are we getting, the more do you see these, do you get more comfortable with identifying them? Right? Now, that means that I now have 2e to the t, 2e to the 2t plus 1, because the square root of something that's squared essentially cancel each other out. And that is this fella. And so, oops, get my right bits and pieces. There we go. We can now get the normal component. It is the magnitude of the first and second derivative, the cross product of them, divided by the magnitude of the first derivative. And it's 2e to the t, 2e to the 2t plus 1, all over. Somewhere or other, I found the magnitude of the first derivative, and it ended up being, oh, come on now, is that not nice? And cancel, cancel, and your answer ends up being that. So there is your normal component of acceleration. And there is your tangential. When you look at them, do you see that they're not the same thing, right? So they have, you know, they contribute in a different way, but they're kind of connected, aren't they? In fact, isn't that one just, this one squared is that one, right? Don't know if that's significant or not, but that's the connection I can see. Now, if you got a question where they wanted you to do it at a particular value, let's say at t equals 1, just for argument's sake.
I got a question.
Yes, question.
You canceled it out, but isn't it 2e to the 2t over?
Oh, check it. But so's that guy.
Well, the bottom one says, oh, so you just.
I just misread it. I knew they cancelled, I just didn't write it down. There. You see it? It is a 2t. Okay, right, so if they ask you to get the answer at t equals 1, at is just 4e squared, and an is going to be 2e. So you see, you just get numbers. But you still have to do all the ugly stuff, right? And if they want to know the answer at 0, at t equals 0, or t equals 5, or t equals 1, you still have to find these two guys, right? And then you can plug in t equals 0, t equals 4, t equals 5, whatever it might be after the event.
I have a question.
Yes.
Let's say you were plugging in a value. Would you be able to do it like, let's say, would you be able to do R first derivative of t cross R second derivative of t, would you be able to plug in the values before you do the cross product? Make
You
that
could.
life a little easier?
You could, would make your life easier. A good point, yes. Yeah, and 99 times out of 100 it would be easier because it's easier to deal with numbers, isn't it, than it is to deal with t-squares and so on. So yes, I would definitely think about that. There's probably a 1 in 100 situation where the numbers are really ugly. And because in these cases, didn't the thing cancel out really nicely? If you put numbers in, you wouldn't notice that so much because they wouldn't cancel, right? They'd just be numbers, right? And eventually, I guess you'd get nice values out of it, but it wouldn't come out quite as clean. But what you said makes perfect sense. I've done a cyclic, I've done that one, I've done an E. Okay, last one. Yeah, we got time. Version of 11. The space curve has got a natural log of t in it. It has a t squared plus 7t and then 8 square root of t. Get 15 minutes. Yeah, should make it. It's a lot of work, but hopefully we'll get it done. And do they want it at a particular value? Oh, good. Let's put Kira's idea into motion. We're being asked to find the tangential and normal, but we're being asked to find it at only one specific point. Now, as you look at this expression, telling me that point is not really what I want. Don't I want to know the t value that makes that point happen? Can anyone tell me what is the value of t that would generate this coordinate?
Would it just be 1?
Which one of the three did you use to do that? Because you just need one, and whatever it is, that's what they're all going to be, right?
I used the third one.
Oh, okay, that works.
What happens to the y value though if it's 1?
Right.
Yeah.
Oh, because I didn't write the question down right. It's 088, in which case it matches perfectly. I was thinking of that one. I was just thinking log of 1 is 0, but you know, as you say, look, we got the answer. Now, I still have to find the first and second derivatives. But because they're only interested in the answer at one specific point, we'll turn them into numbers like it was suggested. And because I believe this would be one of these situations where that would work out well. So differentiate. And this guy is 8t to the half. So that'll get you 4 over square root of t. And now I'll do the first derivative at 1. So that's 1, 9, and 4. You happy about this is the first derivative, but that's the value of the first derivative at 1. To a little squiggly line here to separate it. Now to do the second derivative, I return back here. And if you differentiate this one, you will eventually get negative 1 over t squared. You differentiate this one, you'll get 2. And if you differentiate this one, oh goodness gracious. I'm not going to do that in my head. To differentiate that guy, I need to call it that guy. And then when I differentiate it, I'll multiply by the power, reduce it by 1, and then make it look pretty. And now when you plug in 1, it's actually not that bad. So the second derivative at 1 is negative 1 over 1, 2, and negative 2. So there's our first derivative, and there is our second. So we can use this formula, but with numbers. So I need to find the dot product of the first and second derivative at 1. So it's going to be the dot product of 194 with -1 to -2. And that's 1 times -1 plus 9 times 2 plus 40 times -2. And what's that? -1 add 18, take away 8. I make that 9. Does that look good? Okay. And I also need to find the magnitude of the first derivative at 1. So I need to find the magnitude of this guy. So that's 1 squared, 9 squared, and 4 squared. That's 81 and 16, 97, 98. So I have the square root of 98. So I know the dot product of the first and second derivative at 1, just this guy. I know the magnitude of the first derivative at 1, just this guy. And so I can now get the tangential component, this guy. It's going to be the dot product of the first and second at
Can I
1.
see the other paper real quick?
There you go.
Up
Over the
over-
magnitude at 1. And the dot product is 9 and the square root of 98. Goodness gracious. Can anybody make that pretty for me?
Can't we only just rationalize the denominator?
You could, but you can simplify the denominator first. Square root of 98.
You can pull out a 7, I think.
You can. It's 49 times 2, I believe. Yeah. So you get 7 root 2. Okay. Better than nothing, agreed? It's a little bit prettier. If you want to rationalize the denominator, how about 9 root 2 over 14? That's also quite a nice answer. Moving on then. And we'll take the cross product of the first and second derivative at 1. So it's going to be the cross product of 194 with the vector -1 to -2. -1, 9, 4, -1 to -2. So many i's. So take away so many j's. So many k's. Okay, -18 take away 8 more is -26. -2 add a 4 gives me 2. And 2 take away -9 is adding it, you get 11. So I'm looking at 26, -2, 11. And the magnitude of this cross product is going to be the square root of that guy squared, that guy squared, plus that guy squared. No way in the world am I trying that in my head.
Not that it matters, but I think you dropped a negative from the 26.
Still important, but you're right, it doesn't matter calculation wise. Goodness gracious. Any ideas what the square root of 801 might become?
Pretty sure you can take out a 9.
Let's check it out. 801 divided by 9. Anything else? Try to go through my scheme of things.
3 square root of 89.
What was that?
3 square root 89.
Yeah, I agree with you. Is 89 doable? I don't see anything obvious. Okay.
No.
Somebody say something I can't. I'm trying all the usual ones. 9's not going to do it. 16's not a chance. 25. No, I can't see anything. Okay. Then that's as good as I can get. And we should be able to put it together then and we're finished. The guy that we're looking for is him. So he's going to be the magnitude of the cross product of the first and second derivative divided by that fella, right? And the cross product ended up being that, and the first derivative ended up being I actually ended up being 7 square root of 2, didn't it? I don't think I'm going to get much out of this, but I'll try my best. If you rationalize the denominator, you're going to get 3 times the square root of, well, if you double that, you get 178 over 14. Can anybody do anything with 178? I can't. So I guess it's just, that's as good as I can see it. Okay, so put your last names down. Tell you what's going to happen next week, and then we'll be good to go. We are finished this chapter. The last thing that we're going to deal with, starting on Monday, is we're going to do functions of more than one variable. They're called multivariate functions. And we are going to differentiate them, and it's called partial derivatives. And we're going to find 2 ways to do it. One's going to be partial derivatives, and the other is going to be called the chain rule. And all of that section, the next chapter, all of it is where Calc 4 begins. So in our kind of journey through Calc 3, hasn't it been a bit bitty, right? You've done stuff with sequences and series, and then you did stuff with space curves, and you did stuff with vectors, right? And you did a little bit of this and a little bit of that, but there wasn't any real great coherence to it. For those who intend to move on to Calc 4 is all about multivariate functions. And so the next chapter, the one we do, chapter 14, when you come back and do Calc 4, that's actually where we're going to continue from. And we'll do a little bit of overlap. And my goal is to get that chapter done by Thursday. And that way we can have Friday to revise for your final. And that's pretty much it. We're almost done. Any questions? Now that could mean you haven't a clue what to ask me because there's so many things you don't know, or it could be that everything's cool. I'm going for everything is cool. So have a nice weekend. Your test is available. That's online test number 9. It should be available. You can check it for me if it's not. And bye-bye. I'll see you on Monday. Where I can pick on Eli. I'll try and find a good insult for him. Look, I've only got a week to go, Eli. Unless you're doing Calc 4, I've got to get it in. Well,
Yeah, I know you do.
Are you taking Calc 4?
I decided not to,
You've been
but I
insulted.
am going to kind of miss math though. I think math has been fun. So
It has, isn't it? Math
Yeah.
is magic.
oh yeah, that's for sure.
Poor Tia has decided to take to do the what's that witness protection program, and she's now disguising herself. It probably means that poor Tia's at the college. The college is still wearing masks everywhere, aren't they?
I guess so. Yeah.
Yep.
I don't know.
A pain in the butt. I'm glad I'm not there.
Yeah. But the mask mandate's supposed to end though, right?
Well, I was going to ask you because, I'm so out of the loop. I ask students half the time, has anybody got any idea what the thing's going to turn into? Have you been told what the rules are going to be, if anything? Are they just going to not change, or are they going to change?
I don't know.
I don't know about anybody else, but no.
Nobody's been told anything, so you're in the dark as well then?
No, they just sent us an email like yesterday.
And?
I didn't read it.
Oh, well, that's a lot of
Perfect.
help. Yeah, I've just cured cancer. I just haven't bothered to tell anyone, right? That's pretty useless. God.
All I saw is that they said that the mask mandate on campus is gonna remain
For the next week and a bit, because that's all that's
through the end of the quarter.
Right, but no decision made after that.
Does that mean that they're still?
Because she's that. Right.
Does that mean that they're still going to require like the vaccines and stuff like that?
Oh, who knows? I got my vaccine, and I still caught COVID.
Yeah.
My wife did not get the vaccine, and I gave her COVID. So you tell me where the logic of this is.
I don't know. Funny thing, so my family, COVID kind of came through my family. I have a pretty big family. My oldest brother, he got the vaccine, but out of everyone who got COVID, he got hit the worst. So it's like, okay. And none of us had ever had the vaccine or anything. So it's kind of weird.
I know, and I've got a pretty good immune system because of my job being around people all the time, except right now, right? And I think that may be why I probably did catch it, because I think it's healthy to be near people who are sick because you build up your immune system. And when you isolate, as I have for the last 2 years, teaching inside a room all day and never seeing people except my wife, I think my immune system got weaker because I wasn't exposed to things. So in a perverse sort of a way, it's a good idea to get sick. As long as you're not really old or really weak, then it's a really bad idea to get sick. Yeah. But as long as you're reasonably healthy, getting sick is part of the immune system that your body uses to protect itself.
I used to have a pretty clear system where at the beginning of every winter, it would get really cold and then everybody would get sick. And then I would get a cold right at the same week of every year. I'd get a cold, I'd get through it, and then I'd feel invincible for the rest of winter.
Well, you've done it, right? I've got that.
Yeah, I'm like, I'm done. That cold stuff, don't even have to worry about it. Sneeze on me, we're good.
Well, I'll take your word for it. I don't think I would opt to sneeze on anyone deliberately, but never mind. Okay, bye-bye, guys. If there's any questions, I'm here.
Can I ask you a quick question about one of the homework problems?
Sure, which one?
It is question 23 of the first homework set. The derivatives and integrals. Oh, God, really? Oh, good.
Tell me this is 13-2?
Yes.
Okay, and it's what question number?
23.
Okay, that sounds like it's quite near the end.
Yeah, that's where they start really throwing the hairy ones at us.
Well, yeah, they do that. So I'll write down this guy.
Maggie, did you have trouble with the Z component? Or was it the other one?
I had trouble with, the Z component.
The Z component was the one that, because the other two were okay.
So I have a secant tan. And then the middle one, I don't. I have a secant tan plus t cosine 2t. No, I don't. That's the IJK screws me up. Okay. Then I have a t cosine 2t for the y component. And then I'm going to finish with a sine squared 2t cosine 2t for the last one. Does that sound right?
Yeah.
You'll,
So
you'll
for
see it in a minute. I'll put it on the screen in a second once I've written it all down.
yeah.
Right. So this is the guy we're dealing with. You can tell me if it matches what you believe it to be. A secant tan, this guy, and then that one, right?
Yeah.
Okay, so we're going to integrate each one separately. This guy here, I hope you recognize it because it's a secant.
Mhm.
Okay, and if you get the secant pi upon 4, I'm just going to do each piece separately. Take away the secant to 0, right? And the secant pi upon 4, well, is 1 over the cosine pi upon 4. Cosine pi upon 4 is root 2 over 2, so this guy is 2 over root 2. And that guy, the secant of 0, ends up being 1. And so this guy, if you make it look pretty, ends up being this fella. And so that is your first component. We comfortable with that? Okay.
Yeah.
The second one, which is this integral here, that involves you doing integration by parts.
Mhm.
And according to my answer, pi upon what's in front of me, sorry, says that that answer should be pi over 8, take away a quarter.
Pi over.
Now, if you don't get that, then that's the one I'm going to focus on.
Look, I think I had that.
Did you get this, Maggie?
No.
Okay, so let's do that one. That might fix your problem. Okay, so I need to find t cosine 2t dt, and it's going to be an integration by parts. So I'm going to call this f and this g. And the version of integration by parts that I use is this formula. There's another version of it that uses udv, which is fine. Now, leave this guy alone. If you integrate the cosine of 2t, you will get 1/2 the sine of 2t. Comfortable with that? Integrate a cosine, you get 1/2 the sine of 2t. Take away the derivative of this, which is 1, and you integrate that guy again, and you get 1/2 sine of 2t dt. So we have 1/2 t, the sine of 2t, take away the integral of 1/2 the sine of 2t. And if you integrate the sine, you get a negative cosine, and you get an extra 1/2. 2 negatives make it a plus, so I will get 1/4 the cosine of 2t, and this guy is still at the start. Are you comfortable with that bit? So I'm going to evaluate that at 0 and pi upon 4. You're going to get 1/2 pi upon 4 times the sine of a 1/2 pi, because if you double a quarter, you get 1/2, plus 1/4 the cosine of a 1/2 pi. Take away the sine in nothing times nothing is nothing, plus 1/4 the cosine of 0. So far, so good. Right. This guy is pi upon 8. The sine of a 1/2 pi is 1. The cosine of a 1/2 pi is 0, so you get quarter times 0. Take away 0, and the cosine of 0 is 1, so add a quarter. So you get a pi upon 8, take away 1/4, and that's what they have here. So can you see where you went wrong, Maggie? Okay.
Yeah, I didn't distribute the 1/2 to the pi 4th.
Gotcha. Okay. Now, this is the last fella, which is sine squared of 2t cosine of 2t dt, right? Now, according to them, The answer to this is 1/6. Wow, that wasn't expected. 1/6. Did you get that? Okay. Do you recognize that this is a U-sub question? That's how we're going to solve it. And the U-sub is going to be the sine of 2t. When you differentiate it with respect to t, you'll end up with 2 cosine of 2t. You'll then do a crossover, and you get 2 cosine 2t dt, and then you divide everybody by that cosine guy to isolate the dt.
It's
Are we
been too
comfortable?
long since Calc 2. I chose cosine instead of sine. And then I was like, wait, and then I tried to U sub and then V sub, and then it got way worse before it got better.
So, cleaner this way. You know you have a 50-50 in this kind of question, right? It's either the sine or it's the cosine. It's never sine squared or cos cubed, right? You typically don't do those. If you do one and it's going weird on you, you probably should stop, start the question again and pick the other one.